Here, this is the design and simulation of PV sourced standalone inverter with battery energy storage system. This is the block diagram. Here, this is the PV panel or fuel cell. We can use it. It is connected to the DC to AC inverter, and then it is connected to the load. In between that, we are using a battery energy storage system with bidirectional DC to DC converter. So battery can be either charged or discharged depending upon the load demand and power generation. If the load demand is less than that of power generation, the bidirectional converter will act as a buck converter and the battery will be charged. If the load demand is higher than that of power generation, this converter will act as a boost converter and the battery will be discharged and provide the supply to the load. Here, this is the simulation circuit and this is the PV panel setup. And here we are providing the irradiation. Irradiation, it is initially 1000 watt per meter square until 1 second. After that, it is reduced to 800 watt per meter square. Then after 2 seconds, it is further reduced to 600 watt per meter square. After 3 seconds, it is again increased to 900 watt per meter square. Then it is reduced to 700 watt per meter square. Okay, so we have the power generation will also vary depending upon irradiation. Here the PV panel voltage is around 86 volt and current is around 7.1 amps. And the number of modules connected in series, that is 22. So 30 volt into 22, we will get around 360 volt. And that is connected to the inverter here. And this is inverter control. It will provide the pulses based on the inverter voltage. Here if you see means, this is the PI controller. Based on the reference voltage and the measured voltage, the PI controller will generate the reference signal and that reference signal will be provided for the pulse generation. The generated pulses will be given to the inverter. So based on the load requirement and the actual voltage, the pulses will be generated and provided to the inverter. So the inverter will control the output voltage. Okay. Irrespective of the changes in the radiation and the load demands, the inverter voltage is constant here. And initially the load connected across the inverter is around 500 watts. And after 0.5 seconds, one more load is connected of 1.5 kVA. And after 2.5 seconds, sorry, 1.5 seconds, one more load of 3 kVA is connected here. And this 3 kVA load will be connected until 3.5 seconds. And here at 2.5 seconds, one more load of 2 kVA is connected. So initially 500 VA is connected. After that, it is added with 1.5 kVA. And after that, further it is added with 2.5 kVA. and after 2.5 seconds with 3 kVA load is added, and after 3.5 seconds this 2.5 kVA load is disconnected, so that load demand will be decreased. We have to check how the battery will provide the energy. Here, this is the power demand, that is load power. Yellow curve is the load power. Blue curve is the power generation. And this red curve is the battery power. Initially, the power generation is higher than the load power. So the battery was charging. Okay, after 1 second, the power generation is reduced and the load power is still less than that of power generation. So battery was still charging. After 1.5 seconds, the load power is increased than that of power generation. That means the battery should discharge. So here after 1.5 seconds, the battery is discharging. And after 2 seconds, further the power generation is reduced. And here the battery is providing more power. And after 2.5 seconds, when the load demand is increased, battery discharging power also it is increased. After 3 seconds, power generation slightly increased. So the battery discharging power is reduced. After 3.5 seconds, load demand is reduced. Again, the battery discharging power is nearly zero. It is coming. After 4 seconds, power generation slightly reduced. So the battery discharging power is slightly increased here. So depending upon the load demand and the power generation, the battery will be either charging or discharging. You see here, this is the state of charge of the battery. Initially, it is around 66.4%. It is increased until 2.5 seconds. After 2.5 seconds, the battery starts to decrease. That is, the battery starts to discharge and the SOC starts to decrease here. The amount of charge present in the battery is decreasing as it is discharging. So this is the simulation outputs. Here, the battery will be providing energy or it will consuming energy depending upon the load demand and power generation. If the demand is higher than the power generation, battery will provide the energy and provide the provide the power required to the load. And if the load demand is less than that of power generation, the extra power will be used to charge the battery for later use.